Hello, welcome to Maths with EJD. In this video, I'll be talking about types of Z tests. In the previous video, I already talked about Z tests, but I think it's necessary to state that there are different types of Z tests. So I'll establish that before moving on to other things. Okay, so let's go. Okay, like we already know, Z tests Z tests are statistical tests. They are statistical tests used used to determine if there is a significant difference between sample and population means. Proportions, so they can be population means or population proportions, or even between two samples or between two samples, particularly when the population and the population variance is known, or the sample size is large. And by large, we mean that that's typically n greater than or equal to 30. That is, the sample size is greater than or equal to 30. So let's see. Here are the main types. Here are the main types of Z tests. Okay. Of course, with their formulas. Okay, or I can better write that as this. Just more like repeating the topic. Types. Okay, let me change now. Talk about types of Z tests. So the first one is the one sample Z test. That's exactly the type that was done in the previous video. That's the one sample Z test, which basically compares the sample mean. It compares the sample mean X bar to a known population mean, which is mu. Okay. So the formula is this: Z equals X bar minus mu divided by sigma all over square root of n, which is the sample size. Okay. Then we have after the first one, we have two sample. So imagine you're considering two samples. So you have two sample Z tests, of course, for means in this case, two sample Z tests for means. This one compares the means of two independent samples, the means of two independent samples. And the formula is this. Now, this formula is a bit extended. Instead of just having X bar minus mu, since we are considering two samples, so Z now will be X1 bar. That is the sample mean for first sample. Then second sample mean, that's X bar minus X2 bar, X1 bar minus X2 bar, divided by the square root now of the standard error, or if you like, standard deviation of the first sample divided by the sample size of the first one plus the standard deviation squared of the second one divided by the sample size. Okay, so of course all the x's simply takes the same meaning as in the case of one sample z-test, except that now you have them for, so anywhere you have one, it's for the first sample, while two is for the second sample. So all that. Then we also have number three. Of course, this is to test, to do the test statistic and then compare with the standard value from the table. So number three, we have the test, z-test for proportions. Z-test for proportions. So here, this compares, it compares the sample proportion, which is a small p, it's a small p, to a known population proportion, which you can regard as big P. So in that case, the formula is Z equals small p minus big P divided by square roots of big P into 1 minus big P all over n, like that. So that is number three, z-test for proportions. Then we can also have two proportion z-test, So here we are considering proportions for two samples. So here we have that this compares, it compares the proportions of two independent samples. Okay, and the formula in that case would be this. We have Z, just like the case of means, we have proportion for the first sample minus proportion of the second sample divided by square roots of a small p. So that's square root of a small p into 1 minus p, all of that into 1 over n1 plus 1 over n2. Now, the small p in this case has a special meaning which should be paid attention to. So that small p is really special. Let's see what that is about. Okay, so here now, of course, you already know P1 is proportion for first sample. Okay, let me do some labeling here now. So this is proportion of the first sample. And of course, P2 is proportion of the second sample, proportion of the second sample. But then this P now, this P is actually a pooled proportion, pooled proportion. And that pooled proportion is calculated like this. P equals x1 plus x2 divided by n1 plus n2. That is how you get the pooled proportion. And here you say where x1 and x2 are the number of successes in each sample. Number of successes in each sample. That's what that is about. Then, of course, n1 is size of first sample. Size of first sample. And n2 is size of second sample. Okay, So that's what that is about. Okay, so that is the fourth type, two proportion t-test, two proportion t-test. So let's move on to talk about the last type, that paired z-test. Paired z-test. So paired z-test. That's number 5, I believe. Number 5, yes. So we have 5 paired z-test. And for paired z-test, right, this actually compares two related samples or measurements. It compares two related samples or measurements. Let's see how that is. Okay, so paired z-test actually compares two related samples or measurements. So the formula is this: Z equals D bar divided by sigma D all over square root of n. And then to tell the parts apart, we have D bar is actually mean. It's the mean of the differences. It's the mean of the differences between the paired observations. Between the paired observations. Okay. Then sigma D is standard deviation of the differences. Standard deviation of the differences. Then finally, N is the number of paired observations. Number of paired observations. All right. So since I've already done and I already did a video yesterday that takes care of the first type, which is the one sample Z test, right? So in this, to conclude this video, I'm just going to take an example that relates with two sample Z tests, and from there we can extrapolate for other types of tests. So let's go for that. So I'm going to take an example of a two sample Z tests for means. Okay, for means. So whatever you get for means, you can extrapolate. You can follow the style for proportions and all that. So example of a two sample Z test for means. So imagine that we have this question that a researcher aims to determine if there is a significant difference, there's a significant difference between two teaching methods, which you can call method A and method B. Okay, so, and this is the information for method A, which is sample 1, right? This is sample 1. So for method A, the sample size N1 is equal to 30. The sample mean X1 bar is 30. I mean, it's 78. Okay. talking about, yeah, we are using test scores now. Then we have the population standard deviation for the first sample is actually 10. Okay. Then on the other hand, we have sample 2, that's method B. So the second teaching method, which you can call method B now, is actually sample 2. So for this sample 2, the sample size N2 is 35. Of course, you can see they are obviously large. So that's why Z-test is necessary for them. And the sample mean for sample 2 is 85, whereas the the population standard deviation for sample 2 is actually 12. So this is the information we have. So we proceed to see if there's actually significant difference between the two teaching methods. That's our thing. So the first thing we want to do is talk about the hypothesis. What are the hypotheses in this situation? So first, the null hypothesis. Null hypothesis. So the null hypothesis here is to say the null hypothesis is there is no difference, if you like, significant difference. There's no difference in average scores. There's no difference in average scores, in average test scores, rather. Average test scores between the two methods, between the two methods. In other words, you're saying that mu1, that's the average score for method 1, is the same thing as average score for method 2. Talking about the population, and you're using the sample to determine for the population. So mu1 equals mu2. Basically, that's the first the null hypothesis. Then the alternative hypothesis would just be a negation of that. Alternative, because this is H naught, right? Alternative hypothesis is now H1, or if you like, HA. And what is that? So here now you just negate what you said before. So there is a difference, or if you like, a significant difference. There's a difference in average test scores, between the two methods. So in essence, you're saying that mu1 is not equal to mu2. So that means that the teaching methods are different. Okay, so that's about your hypothesis. So let's talk about the significance level. Usually we would say alpha is 0.05. Of course, you can, if you want it to be higher, you can go for alpha equals 0.01. So just take alpha is 0.05 usually. So the next thing we want to do is to calculate the test statistic. So we say next we calculate the Z-statistic rather. Z-statistic. That's the next thing we go for. And then, of course, since you're using the two sample test formula, so it means Z is equal to x1 bar minus x2 bar divided by square root of sigma 1 squared over n1 plus sigma 2 squared over n2, like that. So if you put the formulas we have in all these things now, you already have x1 bar, x2 bar, that's 78, 85. So that means we have 78 minus 85. 78 minus 85 divided by square root of sigma 1 squared. Sigma 1 is 10 and sigma 2 is 12. So that's 10 squared over n1 is 30, n2 is 35. So that's 10 squared. That's 10 squared divided by 30 plus 12 squared divided by 35. Okay, so that the Z statistic would now be Of course, 78 minus 85 is minus 7 divided by square root of 10 squared is 100 over 30. 12 squared is 144 over 35. And then that is Z equals minus 7 over square root. 10 divided by 30 is like 3.33. Then 144 divided by 35 is like 4.1143. So that Z now is equal to minus 7 over square roots of 7.4443. Okay. And then Z now is approximately minus 7 over 2.73, which is then Z is approximately minus 2.56, minus 2.56. So this is our Z, the test statistic. So the next step now, since I've got the test statistic, the next step is to talk about the critical Z value. So what is the critical Z value? And that is what you get from a table, okay? But since we have chosen alpha to be 0.05, that is easy. So we have for a two-tailed test at alpha equals 0.05, the critical Z values are minus 1.96 and 1.96. Okay, so these are the critical values now, minus 1.96 and 1.96. So then we move on to make a decision. So we make a decision. What's the decision you make based on this now? So you make a decision. So we know that the calculated Z value is equal to minus 2.56. That's from the test statistic. And then we know that the critical Z values from the table, critical Z values from table are minus 1.96 and 1.96. So we now say, since minus 2.56 is actually less than minus 1.96, then we reject the null hypothesis. We reject the null hypothesis. Okay, null hypothesis. So we can conclude now. So we can reach a conclusion based on that there is sufficient evidence. There is sufficient evidence to conclude that there is a significant difference. There is a significant difference in average test scores, between the two teaching methods. At the 0.05 significance level. Therefore, we reject the null hypothesis. H naught, and accept the alternative hypothesis. HA. So on this note, we've come to the end of this video. You want to go over that over and over again, and also try your hands on different questions to be sure you master that. So of course, if you have not subscribed to this channel, be sure to do that. Then hit the notification bell so you can always get alerted each time a new video is released. And don't forget to comment. Let me know if you wanted to teach a particular topic or solve a problem. and like and share so that more people can have access to this. Watch out for other types of tests in the videos after this. Bye.